Picture a place on the map where almost nobody lives, where clouds are a rare sight, and the sun shines almost non-stop for 300 days a year. The Sahara. The largest hot desert on Earth, millions of square miles of sand and rock that seemingly nobody needs. For years, humanity has been fighting over oil and gas. Countries argue over pipelines and deposits. And right here lies this no man's land, where the sun shines almost without a day off. And the technology to turn this light into electricity has existed for a long time. Everyone is familiar with solar panels, and they get cheaper every year. What if we covered this useless piece of desert with them, you would think? What could be simpler? If you estimate how much energy you could really get from such an area, the number is just colossal. If you were to cover a little over 1% of the Sahara with solar panels, it would be enough to provide electricity for the entire planet. All the factories, all the cities, all the homes, all the phone chargers, literally all of humanity at once. And you would still have 99% of the desert left over. It would seem that here it is, the solution that was lying right on the surface this whole time. Simple math, cheap land, endless sun. In reality, talks about this have been going on for more than 15 years. They drew up projects, ran the numbers, discussed it at the highest levels. But not a single power plant of this scale has appeared in the desert. Not one. Why? The first thought, of course, is money or politics. Yes, such projects really do cost billions of dollars and require approvals at the level of leaders from many countries. But there is a second question, a much more alarming one. What if the real reason isn't about money or politics at all? What if the scientist who seriously undertook the task of calculating this idea stumbled upon something capable of calling into question the continued existence of all life on the planet? It is almost impossible to imagine the size of the Sahara from a map. 9 million square kilometers sounds like a dry statistic until you realize that this desert is larger than the United States or China. It stretches across a dozen countries, from the Atlantic Ocean almost to the Red Sea, and if you fly over it for several hours straight, almost nothing will change under the wing of the plane. Just the same sand dunes for thousands of kilometers. Cover all this land with solar panels? A project like that would stretch on for decades. But in reality, to provide electricity for all of humanity, you do not need to cover this entire endless desert with panels. According to various calculations, a territory about the size of one not-so-large European country would be enough. On a map of the entire Sahara, such a plot would look like just a small spot somewhere in one of the corners. Imagine a small piece of the desert covered with solar panels, capable of replacing oil, gas, and coal for all of civilization. And unlike all of Earth's resources, the sun's energy is renewable. Every day, billions of kilowatts of clean, renewable energy simply go to waste. The figure of 1% of the Sahara's area did not come from some viral post online, but from an ordinary thesis paper. Back in the mid-2000s, a German researcher calculated how many square kilometers of North Africa would be suitable for stations of this type. It was pure engineering math, nothing more. But the calculation didn't just sit around collecting dust in a university archive. It was picked up by major energy companies, and then by the governments of several countries. And the topic quickly escalated to the level of international negotiations. Similar calculations weren't just made for Africa. For one region of the United States, the picture was almost the same. An area the size of a single state could theoretically cover the entire country's energy needs. It's just that in the Sahara, this math looks the most impressive. An endless desert, where the land seems to be useless to anyone, sounds way more convincing than one state in the middle of a densely populated country. From the outside, it seemed like the solution was ready, and all that was left was to just go and make it happen. The first serious attempt was made pretty quickly. taking the calculations from paper to a real project, right away on a continental scale. In 2009, they decided to make this idea a reality. A consortium of European banks and industrial giants launched a project with the telling name Desertec. It was supposed to provide up to 15% of Europe's electricity needs. The plan was to place the stations in the deserts of North Africa and the Middle East, and the year 2050 was chosen as the planning horizon. The project's budget was in the hundreds of billions of euros. On paper, everything looked perfect. However, just a few years later, the biggest participants started leaving the project, one after another. In the end, it basically fell apart, having never built a single station of the intended scale. It turned out the problem wasn't about physics or the sun at all. A combination of political instability in the region, a border between two key countries closed due to a territorial dispute, and the outrageous cost of transmission lines over such long distances played a fatal role. The idea died not because of miscalculations, but because of people and borders. At the same time, engineers had already almost figured out how to solve one of the problems. And this is where a much more unexpected story begins. One of the technologies they plan to use in the desert works by using mirrors that heat a coolant. To cool such a station and regularly clean the panels of dust, a significant amount of water is required for every kilowatt-hour generated. In a region where water is more precious than any other resource, this created an unexpected conflict of interest. The station was supposed to generate clean energy, but at the same time, it would be taking water from the local residents, for whom every drop counts. The desert is generous with its sunlight, but it offers no water at all. It was this very issue, not just politics and finances, that almost killed the project while it was still on the drawing board, long before the first foot of power line was ever laid. Let's say that money, borders, and water were somehow all sorted out tomorrow. Then there would still be the question that for a long time no one took seriously. What happens to the land itself when it's covered with dark panels instead of light-colored sand? Sand reflects most of the sunlight right back into the sky. The dark surface of a panel, on the other hand, greedily absorbs this light. Part of it is converted into electricity, but another part inevitably turns into heat right at the Earth's surface. This heat warms the air above the station much more intensely than over the neighboring open desert. The warm air rushes upward, setting in motion a movement that had almost never existed in this place before. This is the exact, seemingly simple change that climatologists began to incorporate into their models. They wanted to figure out what it would lead to if it were replicated not just at a single station, but on the scale of the entire Sahara. Imagine for a moment a huge, invisible furnace, hundreds of thousands of square kilometers in size, spread out right in the middle of the desert. This, in a very general sense, is exactly how a gigantic field of solar panels behaves. The warm air rising above the station strengthens the upward drafts in the atmosphere. And this, in turn, helps clouds and precipitation to form where not a single drop had fallen for years. According to climate model calculations, if about 20% of the Sahara's area were covered with panels, the local temperature above the station could increase by about 1.5 degrees, and the amount of rainfall in the arid belt south of the desert could more than double. It turns out to be a completely unexpected picture. A station built to produce clean energy also becomes a real rain generator in one of the driest corners of the Earth. And this is just a small part of what scientists discovered in their calculations. The question to ask isn't about the panels, but about the desert itself. Was the Sahara always as parched and lifeless as we know it today? The answer shatters our common perceptions. As recently as 6,000 to 11,000 years ago, which is basically the day before yesterday in geological time, A savanna with lakes comparable in size to the Caspian Sea stretched across the area of today's sand dunes. Hippos, giraffes, and crocodiles used to live in those parts. The people of that era left behind thousands of rock paintings of hunts and pastures, which can still be seen on the desert stones to this day. The reason for that green period was a slight shift in the tilt of the Earth's axis, which intensified the monsoon rains. The vegetation served the very same purpose that the dark panels do today. It absorbed sunlight instead of reflecting it back, and by doing so, it strengthened the rains that it sustained. Nature has already demonstrated once before that turning the Sahara from a lifeless desert into a flourishing land is not some fantasy. This is a very real physical scenario that has already played out without any human involvement. What happened to the Sahara 6,000 years ago was a natural process that stretched out over many millennia. Modern models are looking at a fundamentally different scenario. The same mechanism, but set in motion not by nature, but by engineers. And not over thousands of years, but in just a few decades. If you kickstart the same mechanism artificially, using industrial-scale panels, the rains in Africa would just be the beginning of the story. Then, the entire planet's atmosphere would get involved, and a whole lot more would be at stake than the fate of one single continent. On our planet, there's a narrow band near the equator where more than 30% of all the Earth's precipitation is formed. This is what feeds moisture to the forests of the Amazon and the Congo Basin. Calculations show that if you heat up the Sahara with a massive construction of solar panels, this rain band will start to shift north toward the new heat zone. Precipitation obediently follows wherever the temperature is higher. In those same models, the Amazon loses about as much moisture as the Sahara gains. According to various estimates, this amounts to anywhere from 10 to 30% of the region's usual amount of rainfall. For the planet's largest rainforest, a loss like this is already pretty significant. This means a risk of serious droughts, where water was once always plentiful. An attempt to fix a problem in one place can create another one tens of thousands of kilometers away. The heat that builds up over the Sahara doesn't just stay put. The atmosphere and the ocean spread it all across the planet, rearranging the usual air and water currents far beyond the African continent. In these models, it's not the tropics that heat up the most, but the polar latitudes. As a result, the Arctic ice begins to melt faster than usual, losing area year after year. The altered wind circulation, according to the calculations, can increase the likelihood of tropical cyclones off the coasts of North America and East Asia. Storms where they were once considered a rare occurrence. Even a very slight shift in the planet's average temperature, just a few tenths of a degree, is capable of setting off a whole chain of consequences in these scenarios. It would be impossible to predict it in advance just by looking at a map of the desert. But there is a flip side to the very same calculations that scare us with the fate of the Amazon and melting ice. They also point to a clear benefit for Africa itself, and that is worth considering before we keep getting scared. More rainfall means more greenery in the arid belt south of the Sahara. And vegetation, as we have already seen with both solar panels and the ancient Sahara, in turn only increases that same rainfall. The good news is that a cycle like this, once set in motion, starts to sustain itself. Nature no longer has to put in the effort all over again each year for this effect to continue. In some calculations, the effect from just the wind and solar farms in this belt accounts for up to 80% of the total increase in rainfall, thanks to this very chain of events. The same exact climate change can make one continent greener while simultaneously drying out another. And this is not a flaw in the model, but its key point. Scientists openly admit that the calculations are still missing one important component: dust. the very same dust that the wind regularly picks up from the surface of the Sahara and carries across the entire Atlantic Ocean. This dust serves as a source of minerals for two distant ecosystems at once. For the very same Amazon rainforests and for the oceanic plankton off the coast of Africa, which are in desperate need of these minerals. If a solar panel farm noticeably greens the desert, the amount of dust kicked up will inevitably decrease. And then, the real consequences for the Amazon could turn out to be even more serious than what existing calculations have already shown. The authors of these studies say so themselves, with complete frankness. We are only just beginning to realize what would actually happen if something like this were built in reality and not in a computer model on a screen. Humanity, as it turns out, already has unintentional experience setting just such a mechanism in motion, only with the opposite effect. Back in 1975, a climatologist put forward a hypothesis that was later confirmed in practice. Overgrazing in the arid belt south of the Sahara destroys the vegetation cover. The exposed, light-colored ground begins to reflect more of the sun's rays than before, when it was hidden by grass. The air over land like this cools down and sinks instead of rising upwards. And this means that rain stops forming, which in turn kills off even more vegetation in the surrounding area. So herders, completely unintentionally, were making the droughts in this region worse with their flocks for many decades. The mechanism that could turn the Sahara green with solar panels turns out to be the same one people used to accidentally turn the savanna into a desert, just pointed in the opposite direction. Let's go back to the image that started it all. A tiny percentage of the area, an imaginary little square on a map. A promise to cover the energy needs of all humanity with one bold engineering solution. But now we have answers to both questions posed at the very beginning. The project wasn't built not because the idea was bad, but because borders, money, and water turned out to be way more complicated than any formula on paper. And if it ever does get built, it won't just be about clean energy. The planet is much more interconnected than it looks on a globe, and rain taken from one continent could very well fall on a completely different one. A dried-up rainforest, melting ice, more frequent storms. Each of these consequences taken separately looks like a disaster for one specific region. But together, they add up to the very thing the first question of this story warned us about: a threat to the stability of the system that life across the entire planet depends on, not just in one part of it. The Sahara seems like the most deserted and quiet corner of our planet. But if the climatologist's calculations are correct, this is precisely where one of the levers connected to the Earth's entire climate system is located, and humanity still hasn't decided whether it's worth pulling it at all.